Okay, batterying. Oh yes, that's right. So, pens, here they are. So we've been talking about two main ideas in the past few days. And one was a way to quantify what's called center, so measures of center. And one's a way to measure variation. Let's take a quick overview back at those ideas again. Pick one of them and tell me as much as you can remember. Or tell me one thing, I shouldn't say as much. Tell me one thing you remember about one of those two things. So either center or variation, your call. Go ahead, Leila.
So mean or average.
Good, good. Would be an example of, go ahead.
It is when we take the whole bunch of numbers and we adding them together like cumulative and then divide by the number of how many of them were.
Yes.
So,
and what's the point of doing that?
So what we do, we actually try to find a balance or sharing equally between them.
Love it. Yes. And that's fantastic. That's exactly what that whole summing and dividing thing gets you to do. Assuming that we have the same number of things, what number would guarantee that every single element of the data set has the same number of those things? Exactly. I had an image from the other 243 class, and I don't know why I came up with this. I'm Italian. And Italians always keep these like baby blue urns or big urns on their outside porches. I'm not exactly sure why. My grandmother always had these big urns on their outside, like not like a what's it called? Not a death urn. What's when you burn somebody's body? Cremation. Not a cremation urn, but just like a big blue, like a planter almost. A lot of my uncles used to put their cigarettes out in it. But I had this vision of an urn by the door, and as you guys come in, you just throw your keys in the urn. Idea. So you get this collection of keys by the end, and then you shuffle them all up. Not that we would do this because it would piss everybody off. But the idea of the average is shuffle up those keys, dump them all out on a desk, and say, how many people we got in here? We got like, what, 20? Let's make 20 piles that are all the same size, and then give that out to everybody. And that's the same. Then we have the same number of keys. We've got the shared, balanced number of keys for every single person in the room. So for some reason that popped into my mind walking through there. The Italian big nose. Yeah. So mean or average, beautiful. What else? Medians and modes, good, good. Medians and all measures of centers. Tell me about these guys. Why we like these guys? Or why we don't like these guys. That's also cool.
Mode's the number that most consistently appears.
Good, good. This is your most common, most frequent. Most common or most frequent. Why do we like the mode as a measure of center?
Easy to
Very easy to calculate, Ellie. Very easy to calculate.
In the rate.
Say that again, Jordan?
In the rate pool, it's usually the one that, for majority rules.
Very nice. It's the most flexible. You can use it in the most places. For qualitative data, for example. Qualitative data, non-numerical data, this is the only choice you have as far as centering. When you have high skew levels of data, which one shouldn't you use when you've got highly skewed data? Or you should be careful about using, I should say. This guy. This guy is the one that gets affected by highly skewed. So remember those tailing off distributions? The average tends to chase those outliers. Whereas these guys don't care about them at all. Go ahead, Jordan.
A question for mean, median, and mode.
Yeah.
Are they all averages?
Yes. They're all averages, quote averages. So when somebody says average, they could be using any one of these three things. But the mathematical arithmetic mean, quote, literally average is this guy up here by the sum and divide. But yeah, Jordan's got a good point. When somebody uses the word average in the media, they might not be talking about this. Very often they're talking about this, the average American family. By what definition? Are you talking about race? Because that has to be a qualitative thing, or a qualitative thing, which means it has to be a modal thing. Are you talking about average income? Because that could be either median or average, depending on what you're doing. So, yeah, the word average is used pretty loosely in the world, but mathematically it actually just means this particular measure right here, sum and divide. Good question, good question. What's this guy, the median? What's he all about?
geographical center.
Geographic center, Rach, yes. This is your geographical or positional center, yeah. So basically, the reason why the median doesn't care about crazy outlier values compared to the average is because the largest data point in a data set is just that, the largest data point in a data set. So if that largest data set was, if you're talking about house prices, for example, and you've got a neighborhood full of houses that cost anywhere from $150,000 to $250,000, and then you've got this one house on the corner that's $14.2 million because it backs up to the river and it's got 200 acres on both sides of the river. The median isn't going to be skewed by that because all that house is the most expensive one. It's right next to the next one now, which was $249,900. But for the average, because of Elena's balance point, you've got this balance point of all these houses values, and then you've got that one way out there. That one way out there is going to pull this that way to get towards that to balance it. But the median says, to hell with that. It's going to take all these points and flatten them down into a straight line, and it's going to put that guy right next to everything else, just like that. And it's going to go cha-cha-cha-cha-cha-cha-cha. You're going to find the median that way. So, good. So, knowing which one to use becomes a matter of feel. So, rest assured, next Wednesday, I'll say, here's the data set. Give me the average. Give me the median. Give me the mode. I won't say which one are you going to use and why. Because that, I don't think, we need to keep talking about this for the entire term before we get a feel for that. It's the kind of question I like to ask my 244s. Like, which one do you think we should use at this point? Should we use the average? Can we feel okay about using the average? I know I've talked about it in class. We've actually talked about it freely in class, but it's one of those things that after 3 or 4 weeks of a stat class might not be 100% certain as to how skewed is skewed enough to be too skewed to talk about skewness-ish. Cool? Good. Well, this is wonderful. You guys went straight to measures of center. Nobody picked variation. Do we care about variation? No. Just cross it off and talk about it. So I saw a no and I heard a yes. So on average, we're feeling neutral. No, terrible mathematics. Why do we care about variation?
The consistency.
Yes. Yes. It talks about either inconsistency or consistency. What else does it talk about?
Stability.
Good. Stability was another word we use. I love that. Stability.
Or instability.
Or instability, right? Or instability. Good. Good. Why do we need to measure that kind of a thing? Why would you care? Suppose, let me pose a question for you. Suppose you're buying tires for your car. And you go to the store and you ask a bunch of questions of the folks who work there, like, okay, so how many miles on average do these things get before I have to replace them? And they say, well, brand A, you get about 40,000 miles before you have to replace them. And brand B, you got about 38,000 miles before you replace them. So maybe you want to go with brand A, because brand A gets about 2,000 more on average before you have to replace them. But I would ask something else besides that. I'd say, what is the plus or minus around that 40,000? If it's 40,000 on average, plus or minus, say, 10,000 miles, or 38,000 plus or minus, say, 2,000 miles, the 40,000, although it has a slightly higher average, also has so much variation that you might get tires that only last 30,000 miles before they need replacing. Now, you might also get a pair that lasts 50,000, or maybe even more, as we'll see today. There's many ways you can interpret that standard deviation. But the consistency, you might say, well, 38 and 40,000 are just about the same. Just about the same, so why don't I go with the tires with less, unless you feel like gambling. Unless you say, let's take the gamble. Let's gamble and say we get the 50,000 mile tires. Well, you might get the 30. It's a gamble. It averages to 40. But are you a Bert or are you an Ernie? That's the question, right? When you want tires, Bert or Ernie? That's why we care about this. It helps us make decisions.
And the price also, excuse me.
Well, but assume all equal. Everything's equal. Assume that A and B have the same. Definitely, price is definitely an issue. But what I'm trying to say is, assuming that the price is equal, the averages are equal, they're essentially the same tire. This is a question we might not always ask, and it's not always offered to us either. And a lot of folks don't even know what the answer is. And I get to this, speaking of tires, quite a bit, talking about, well, today of course it's gorgeous, Monday was new and snow. But studded tires versus cyc tires versus all-season tires versus snow tires. You know, all these studies have been done, but the studies that I've seen don't give me any data that's actually usable. Studded tires do better on sheet ice. Where? Show me the study. But the study doesn't say that. It says the tires are all the same, but somehow that becomes studded tires are better on sheet ice. I've looked at studies in Alaska, in Sweden, in Norway, I believe one was done in Montana. None of them are conclusive. But somehow that becomes studded tires are better on sheet ice. I don't know, Jenny, you see it.
So what kind of tires do you have?
I ride a bike. I have mountain bike tires, 2.5 inch wide. They're Maxxis Mobsters right now. And right now, I'm Maxxis White Wall Euro roadie tires because it's a nice day. But yesterday it was Maxxis Mobster 2.5s, 25, 30 PSI. It was a sweet ride. Monday was a hell of a ride. I did a lot of slip sliding here and back. Yesterday with the mountain bike, pleasure, absolute pleasure. Very slow. But cool? Now, what I want to do today is kind of nail down some techniques and some generalizations we can apply to this measure of variation. So this is like a big overview of consistency versus inconsistency. But we can actually get more from data than just consistency or inconsistency. We can actually make predictions based on data sometimes. For starters, friends, look at your data sheet. On your data sheet, your first data set is pulled from Ashley et al., which is a, oh, there you go, grab that, Rob. You've got the title of the study is Nutrient Adequacy During Weight Loss Interventions, a randomized study in women comparing the dietary intake in a meal replacement group with a traditional food group. So that's a mouthful of a title, as they often are, because usually these research studies are looking at something very, very specific. And I don't even really care about the research study itself. I was stoked because I got real data from it. That's what I was stoked about. I got some raw data. Yay, us. So what I want you to do is I want you to take a look at those 35 numbers right there. Let's just pretend that we're talking about those 35 participants in the study. That's it, just those 35. They were on a weight loss intervention. That's what these 35 folks were doing. And these are the weight changes by the end of the intervention. My question for you, based on those 35 values, is the weight loss intervention working for weight loss? That's my first question. Those of you playing the home game, here's your data set. Yes, very nice. Okay. Is the weight loss intervention, can we call it a weight loss intervention with data like that? Can we call it a weight loss intervention with data like that?
Well, it's kind of hard because you have like the big outliers. It's like 21 and 16.
Ooh, we've got big outliers. So I love this. The first thing Haley sees is she's like, wait a minute. It might be hard to talk about what, for example, Haley?
The weight loss
The weight loss on
average.
on average, because you got these goofy outlier these data set values that might be pulling, if you will, the data one way or the other. So that's something to consider. Let's keep that in the back of our minds, friends, okay? Let's keep that in the back of our minds. We may have some skewed high or skewed load data points that might pull the average one way. That might want to consider medians instead in that case, right? Instead of which one did you see? The 16?
And
21. So there's a 21 in there. So somebody gained 21 pounds. Yeah, there it is. Somebody actually gained 21 pounds on the intervention.
And lost my.
But then someone lost 50.
And lost 58. So the average is going to say, wow, that's 58 spots left of zero, and that's 21 spots right of zero. But the median says, what the hell? It's just 35 things in a row. I'm going to pull the 18th one, and that's the actual median. So we'll consider both of that. I like that. I like that very much. Other ideas. Works, not working. What do you think?
It's just like all over the place.
It's all over the place, and that's what raw data often does, friends. Raw data is tricky because raw data will often be all over the place like this. So what do you say we organize this data? Yes, I think that's the best thing to do with raw data is organize it. Now, I like having the raw data. I love having the raw data, actually. But let's organize it. The first thing I'd like to do, let's practice our one-var stats. Grab this data, run it into your machine into one of your lists. Like Bert and Ernie. This is like Bert and Ernie, but like on steroids because we have more numbers to play with.
So just put it in one list.
Yeah, just grab one list. Yeah, we're going to deal with how to deal when you have raw data, and then also when you have group data. So we'll do one at a time. Right now, we'll deal with raw data. So turn your TI on.
Yes. Asking
Grab. Yes, please ask. Yes. A TI or this program? Oh, where's the best place to get a TI? Craigslist, if you can. Craigslist, if you can get one used. Walmart, price-ish.
Walmart's gonna be the cheapest.
Weird, I don't
You could maybe always look on like eBay too or something.
Let's see what we got here. Sort by price, low to
I don't know
high.
where I got mine.
Let's see. $6.95. Whoa. Okay, that's probably not right. It's $40 from 5+ stores. So eBay 40, eBay 43. A lot of eBay. A lot of eBay. Now the trick with eBay, can you get it quick enough for your own? Yeah. So I would check. See if you can check local before you go and grab it new. Try used. Try Craigslist. Try eBay. Walmart sounds. I'm guessing like, is there an Office Max in town still?
I think so.
Yeah, still an Office Max. A big box store is going to give you a better price. You can get them at the bookstore here, but you'll pay a premium because you're walking down the hill and going to the bookstore. So not to slam the bookstore, please.
Right.
But you're paying a premium for the convenience. So there's many places.
I would say if you're gonna go somewhere in town, I would go to
Yeah, probably the best price.
Yeah.
Probably the best price. Or if you can get a store to do a price match, maybe bring an ad that has their price and see if they'll either match it or beat it.
Which Walmart sometimes does that.
Well, other stores might do it for
Yeah.
Walmart's prices
Oh,
too.
yeah,
Possible.
Yeah.
Because you know they save you $2,700 a year no matter where you shop.
Right.
So, you know. All right, let's get some data. I'm gonna stop talking and start typing.
Sean, excuse me, before we're doing that, could you please remind how to get rid of all of them? Because, you know.
How do you get rid of all of them?
Yeah.
I'm gonna delete this. Put your blinker up on top of L1,
Uh-huh.
press clear,
Okay, that's.
and then press down.
Ah, yes. that's
Yep,
right.
yep.
Good. That's what I did.
Easy to forget how to do, but one of the things we'll do over and over again in here. We'll make it easy. What's that?
Don't press delete, because then.
Don't press delete, then you have to get it back. Yeah. Is anybody missing L1? It happens. Yeah. If that happens, just put your hand up and walk it through the steps to get it back. Not a problem. Doesn't matter what order you go in. I'm going to go down, because it's less chance of Sean getting lost if I do that. Oops. Those of you watching at home, I apologize for this bit. What kind of data is this, friends?
Raw.
Well, definitely raw. Good. It's raw. It's not grouped. I'm not giving you a histogram here.
Variation.
Say that again?
Measure the variation.
We're going to measure the variation, but you're thinking too micro, Robin. Jordan's going to macro. You're going to micro. Somewhere in the middle. It looks discrete, but it can't. It's quantitative. Sure is, because it's numerical. It looks discrete, but it's not. It can't be, can it? What's being done?
Measuring
What'd you say, Robin?
Measuring
She's measuring weight. It's rounded off to the nearest pound. But I guarantee, I'm about to type -11. I guarantee that that person didn't lose 11 pounds. They lost 10.9735, blah, blah, or 11.34, blah, 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 blah. And they're just truncating it off at 11. Because it was measured, it's continuous data. Fair enough? Good. Yes. Very, very good. Oops, 55, no, 25. Eight. We often in our lives treat continuous data discretely by rounding things off. How long does it take you to get to work? People always ask me that. When you bike to work, how long does it take you? I'm like, between 15 and 25 minutes. It's never exactly 15 or exactly 25 or even exactly 20 or anything like that. It's always something around there. But because you're measuring time, weight, length, things like that, how long is your trip to work? It's about 6 miles. Well, not really. It's a little bit over. 6 point blah, 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 blah. But the blah, 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 we just ignore, and we go with the whole number, discrete looking value. 6-ish. 175-ish.
My son says ish.
Oh, it's a wonderful word. It's so much of our lives are ish. If anybody's ever done woodworking, especially in the yard, ish is a way of life. Ish is a way of life. Wait a minute. See now.
You went to 41.
I did, which means I went to 40, which means I typed 5 extra things. I did, which I shouldn't have been talking while I was doing this. Oh, I bet you, no, let's go back and look again. I shouldn't have been talking while, this is why Sean should not talk while entering data. Okay, so negative 14, 34, 16, 9, 33, 38, 58, 25, 25, 0, 11, 25, 7, 17, 18. Ah, I typed that row twice. There we go. Now we're golden. I hope. Unless I did the same mistake somewhere else and forgot a list, but I'm going to pretend that that's okay. Now, just so you know, right now your data is just in the order that it came to you raw. This might come in handy. It might come in handy to have that data sorted, so it's in smallest to largest, largest to smallest. So a real quick trick to do that, if you go back to stat, the stat button, either sort number 2 or number 3, sort A or sort D. We'll get that guy for you, and I'm going to pull this TI down. I just realized that that's going to be hard to see at home. There. So I'm going to go sort A, which means ascending. So it'll go smallest to largest, and then you have to tell it which list to sort. So in this case, L1. Remember how to get L1? Heck yeah. Second one, and then close. Love that math excitement. So second one gets you L1, and then just press enter. And if you go back and look at your data again, it'll now be in order. So negative 58, negative 38, negative 34, and so forth, all the way up to the
Where's sort? Sorry.
Just go stat, and then it's either number 2 or number 3. Addie, if you want to go descending for whatever reason, go stat excitement. Jordan Cartwheel, yes. Cool? Now, very often you don't need to sort data. Very often you just need the raw data in it, and the TI will do a level of sorting for you. But the overriding meta-analysis might require that your data is in order. So just keep that in the back of your mind. We'll come back to that again.
So sort A, then L1?
Yep, then L1, then enter. And then you have to go back and look at your data. It should say done at that point.
Type L1 in?
Second one. Second and the number 1, that gives you L1.
Oh, okay, sorry.
Now, first thing, practice. Go get me all the measures of center and variation from this data set that you can.
Oh yeah.
Boom, boom. So I'm going to put this, I'm going to try this. I'm going to put the TI partially up there. How do I stop the screen from going? All right, well, we're not going to, I guess. We're just going to put the screen up here.
Does it give you the mode?
It does not.
Okay.
That you have to go back and look for that one. That's the one, which is, now that it's in order, is easy to find. So Haley just found one nice happenstance of putting the stuff in order. Is the mode will be easier to find if there is a mode. And I noticed I typed 2 6s, so there's at least one mode.
Yeah.
Okay. So for the weight loss data, our summary statistics. We got an average, we got a median, we've got a mode, at least one, and we've got a sample standard deviation. There are other summary statistics, of course, but these are the ones I want to focus on right now. And 3 of these 4 are going to come automatically from running, do you remember?
1 bar stat.
1 bar stats. So let's go through that. Stat, calc. 1 bar stats is the very first one. Do I have to put anything after that?
No.
Not in this case because I put my data in, and L1 is where it defaults to. So if your data is simply in L1, you can just run 1 bar stats, and it's going to give you everything you need. So right here, boom, enter. All right, we got ourselves some values here. We got an average weight loss of about 14.7 pounds-ish. Let's just call that negative 15. Since everything else is rounded off to the nearest whole number, let's round our values off to the nearest whole number 2. So on average, people lost 15 pounds in this study. Of those 35 people, they lost on average 15 pounds. What's the median? Where's that going to be, friends? Yep. Good. It's in the middle of a number of cases, Rob. It's in the middle of the data set if we line them up in a front to back. It's also in the middle of the bottom screen, which is right there. Negative 17, so it's pretty close. It's pretty close to the average. Do we have we have at least one mode, right?
It's 6.
Is it just 6? There's 2 6s.
Yeah.
Positive 6.
Yeah.
positive 6.
There's two negative 25s though.
Oh, yeah,
Ooh.
there's
So-
4 negative 25.
Oh, there's 4 negative 25, so our mode is actually negative 25.
Just kidding.
Well, that's okay. We'll let you slide on this one.
Paying attention.
That's quite all right.
Wait, yeah, there's one.
That's okay. That's okay. So there's the most frequently occurring is negative 25, and then again, that, friends, is the reason it's nice to have stuff sorted, because that block of numbers is going to jump out at you.
And that's just this one, right?
Yeah.
16.
Cool.
Five.
And last but not least, what I'm interested in
Almost.
is the sample standard deviation, which in this case is
16.4.
about, right, 16.4. Go ahead and call it 16, just to round off to the nearest whole number.
Wait a minute.
Mm-hmm.
No, because if we actually round it, it will be actually 16.5, which is actually 7.
But to the nearest whole number.
Huh?
To the nearest whole number
Okay.
is 16. No, don't double and triple round. That's a very good point, Elena. Don't triple round. So, for example, suppose this was this is 16.445.
Yeah.
So you might want to say, well, that 5 makes this a 5,
Yes. Yes.
and that's a 5 that makes this a 5,
Yeah.
and that's a 5 that makes this a 17.
17.
That's triple rounding.
Okay.
If you round to the nearest whole number, you just look at the decimal right here.
Okay.
And that's 4, so we keep